So in message authentication code, we talked about how hash functions actually provide a weak notion of integrity. لأنه anyone can compute a hash function and then basically seize the code and then or see whatever you get as an input and then use it to recompute the hash function again and send the hash. It doesn't actually give you a real sense of integrity protection. Like in message authentication codes work differently, and then there is another different solution, which is the digital signatures. So how does message authentication codes work? So أنت عندك sender. So sender wants to send the message, but they want to make sure or give something with this message, which is this thing, the MAC, that if anything changes in the message along the way, the receiver can know that this message have been changed. What we put is we put this message here into a MAC algorithm, and then we also put a key. And the key is shared between the sender and the receiver. And then what happens, you actually send the message itself and the MAC of the message. ليش؟ لأنك أنت you don't care if people see the message. All what you want to make sure if the message get changed, you detect that it's changed. And then there's the network, it sends that over the network. The receiver receives the message at the MAC. When the receiver receives the message in the MAC, the receiver puts the message again in the MAC algorithm and then puts the key that is shared, and then he gets this orange MAC. And then the question is the MAC sent equal to the MAC that he just computed? If yes, this means the message was accurate. If no, معناها either the MAC got changed along the way or the message got changed along the way, but anyhow, the receiver would say, sorry, but the message have changed. So the interceptor, he might see the message, see the MAC. But if they manipulate the message, they have to manipulate the MAC. And to recompute the MAC again, we know you have to insert the key. But anyone in the middle does not have the key, so they will never be able to actually recompute the MAC. So it ends up happening in the receiver, the interceptor. If they change anything in the message, they actually cannot compute a correct MAC. And if they use the same existing MAC, the problem with it is the receiver would know that the MAC is incorrect. So one of the most common ways to implement to implement MAC is HMAC. So it takes H from a hash, and this is an RFC 2104, and it simply takes the message, احنا شفناها قبل شوي, and then concatenate the key معاها as the input, right? And then hash this, and then do another concatenation of the output with the same key again, and then hash all of this. So we do hashing twice to prevent some attacks that exist today. وحتى the key is actually on the left side, not the right side of the message, to also prevent another attack if the key is on the right side. So even here the key is on the left side. So this is what we have. And this is the key that we just showed and how to use the key and then create an HMAC. So this is just, to complete the MAC, we'll continue to talk about the public key encryption and the digital signatures as asymmetric cryptography. لأن كل اللي تكلمنا عنه, the encryption key and the decryption key both are the same. Asymmetric cryptography تقول لك the encryption key is different than the decryption key. And then we will talk about how do you actually generate those keys. Then كل اللي تكلمنا قلنا like the key is shared, the key is shared, the key is shared. So how actually do you really generate the keys هنا؟